So this section covers density. So remember, volume is the space that a figure occupies, mass being the measure of how much something weighs, and then density is a measure of how much matter is in a certain volume. The mass of an object divided by its volume is equal to density of that object. So here we have a loaf of bread has a mass of 500 grams and a volume of 2,500 centimeters cubed. What is the density of the bread? So remember, density is equal to mass over volume. Well, we've got our mass here, and we've got our volume here. All right, so that means to find the density, we're going to take the mass, which is 500, divided by the volume. And in this case, we get that the density is 1/5, or in this case, 0.2 grams per centimeter cubed. A block of wood has a mass of 6.0 grams and a volume of 12 centimeters cubed. What is the density of the block of wood? So density is mass, so in this case 6 over volume, which is 12. So that's a density of 1/2, or in this case 0.5 grams per centimeter cubed. What is the density of a block of wood measuring 0.9 centimeters by 2 centimeters by 6 centimeters? And that has a mass of 5.4 grams. They gave us the mass, but we need to find the volume using these measurements. Well, it's a block of wood, and so we're assuming it's a rectangular block of wood. So to find the volume, we really just need to multiply all these together, because the base would be 0.9 times 2, and then times the height, we'll say is the 6. So the volume of that piece of block of wood is 10.8 centimeters cubed. So density is mass over volume, which in this case is just 0.5 grams per centimeter cubed. Question 4, the density of a substance is 4 grams per centimeters cubed. If the sample substance has a volume of 25 centimeters cubed, then what is the mass? So in this case, we're going from, we have density equals mass over volume, and they give us the density and the volume, but they're having us work backwards to find the mass. So we plug these items in. So the density is 4, we don't know the mass, and we know the volume. Well, remember, to undo division in this case, we would multiply both sides of the equation by 25. In this case, we get that the mass is equal to 100 grams. You have a lead ball with a mass of 420 grams. The density of the lead is 10.5 grams per centimeter cubed. What is the volume of the ball? Same idea. They have density equals mass over volume. They've given us the density at 10.5. They also gave us the mass of 420. And they're asking us to solve for volume. I'm going to get the volume out of the way, or the V, by multiplying it to the other side. So I've got 10.5 V equals 420. Then I'm just going to divide by 10.5. And so in this case, the volume equals 40 centimeters cubed. What is the density of the prism to the right if it has a mass of 3,200 kilograms? So to find the density, we first have to find the volume. So in this case, we'll take the area of the base, which would be 24, times 20, times the height of the actual prism, which would be 10, and we'll calculate the volume. In this case, I get the volume to be 4,800 centimeters cubed. Then we keep in mind that density is mass, so we have 3,200 over volume, so 4,800. And we should get that the density in this case is 0.67 roughly kilograms per centimeter cubed. Question 2, what is the density of the rectangular prism at the right if its mass is 46 kilograms? So they give us the mass. Once again, we've got to find the volume. So the base here we'll say is 5 times 3 times the height of the prism, which would be 4. So the volume in this case is 60 feet cubed. So to find density, we take the mass, which is 46, divided by the volume, which in this case gives us a density equal to 0.77 kilograms per cubic foot. Question 3, same idea. We're going to find the volume because they gave us the mass. So to find the volume, we have to find the area of the base here. Well, the base there is a triangle, so that's 1/2 base of the triangle times height of the triangle. Let's put this together. Times the actual height of the prism, which in this case would be 5. So volume of the triangular prism is 1/2, or is the base, the area of the base, times the height of the prism. So in this case, the volume of our triangular prism here is 150 meters cubed. Then to find the density, we take the mass, which is 1.2, divided by the volume, which is 150. So the density in this case is 0.008 kilograms per cubic meter. Find the density of the following cylinder with a mass of 6.2 grams. So remember, to find the volume of a cylinder, its base area, which in this case for a circle is just pi times radius squared. So in this case it's 3 squared, times the height of the actual cylinder, which in this case would be 8. So in this case, our volume is 72 pi, or right around 226.2 centimeters cubed. Then to find the density, remember we take mass, so 6.2, divided by volume, 226.2, and our density in this case comes out to be 0.027 grams per cubic centimeter. And then last but not least is, what is the density of the cone to the right with a mass of 25 grams? So once again, we were given the mass, we just need to find the volume of the cone. So the volume of the cone, 1/3 the base area, which is a circle, so pi times the radius squared, times the height of the cone, which would be 12. So we can go ahead and multiply all that out. We get the volume to be right around 314.16 meters cubed. Then to find the density, we take the mass, in this case 25, divided by the volume of 314.6, and we get the density of this cube to be 0.08 grams per meter cubed.